Hi everyone, my name is Ashes. Today I'm delighted to give you Scylla streaming and the repair updates. It's all about the performance. So first we'll take a look at the streaming. So what is streaming in Scylla? Streaming is an internal operation to move data from node to node over the network. It's a foundation of the various Scylla cluster operations. For example, you can use streaming to add node, to remove node, or rebuild the node, and etc. This is how streaming works in Scylla. So the sender will use a C-star RPC calls to send the data to the receiver. After receive the data, the receiver will apply the data to memory table. And after that, the memory table will flush the data to disk if the memory table is full or periodically. We have some improvements in streaming. One improvement is that we skip the memory table and write to SS tables directly. We can do that because data is already sorted, so there is no point to sort it again. With this, we will have less memory consumptions because no data for streaming is stored in the memory table at all. The saved memory can be used for user requests. We will also have less CPU consumptions because there is no sorting or inserting operations. We will also have bigger and fewer SS tables because the whole streaming session uses a single SS table, not like before. The memory table will flush the data to disk from time to time and generates a lot of smaller SS tables. With this, we will also have less compactions. So this reduces the CPU consumption. Another thing is that we now use a newly introduced C-star RPC stream to send the data. This means we'll have less RPC calls. Here are some test results. We run the test on AWS S3. We tested the time to do the rebuild operation, which of course uses streaming under the hood. So by the way, this will also improve the time to add the load performance, which we just heard about the talk about, from Grab. So the time I dropped by 70%, and the bandwidth improved by 240%. It will make the cluster operations much faster. Now, repair. So repair is an important maintenance operations that can detect the mismatches between replicas on different nodes, and it can also fix the mismatch for the replicas. So this is a repair we currently have. It's called partition level repair. With it, we do 100 partitions per checksum. The problem is that even a single row mismatch will cause the whole 100 partitions to be synced. So even a single partition can be very large. In some cases, not to mention 100 partitions. This will cause significant unnecessary unaware data transmission. So this will increase the repair time. Another problem is that we now do two-stage repair. So we first do checksum, to find the mismatch. Then we will do the streaming using the streaming services to fix the mismatch. This means we will read the data twice, one for the checksum and one for the streaming. Now I would like to introduce a new repair. It's called row level repair. Well, with it, we do 1 row per checksum. And we also use a set reconciliation algorithms to find the exact mismatch and only exchange the mismatches over wire. So there is no unnecessary data transmission. Another thing to note is now we have the single stage repair. That means we will reuse the data read for checksum and store it in the buffer. If there is any mismatch, we will reuse the data directly and send it to the nodes. So with this, we will only have to read the data once. This is some of the tests. We also run this test on AWS. So we have tested the 3 cases. The first one is a completely unsynced case. So the time to repair dropped by 20%. The second one is a completely synced case. The time dropped by 45. The last but not least one is a almost synced case. I think this is the most practical scenario if you run repair regularly on your cluster. So the time dropped by 80%. One thing to note is that the amount of data on wire we saved with row level repair. So before it's about, in this case, it's about 100 gigabytes. And with a new repair, the data we send on wire is around 1 gigabyte. So the difference is 100 times. Yeah, thank you.